Hey everyone, so in this video I wanted to show you the solution to the Mecanum Drive Kinematics project. Now this project was pretty difficult, and if you couldn't figure it out completely on your own, that's fine. You can maybe use this video as something to help you, or maybe you can keep going as you go through this or something like that, however you want to do it. But this video I'm going to be going through the solution step by step. So make sure that you're on your new branch of your project. So whatever it is, you need to make sure you're on your new branch, not on it. I know mine says main down here, but you want to make sure that you're on whatever the branch happens to be called, and it should be in the description of the Mecanum Drive Kinematics video. Anyway, so first thing, part of this project, we're going to want to create a scanner, obviously, because we need to get that user input to get all those numbers. So I'm going to create a scanner, and I'm going to give it the name of scanner, and we're going to make this, because it's a reference type, we're going to make it equal to a reference to our new scanner, and I don't want to use that. I want to use the system.in, just like that. So I now have my scanner right here, just like that, and we're going to need to get that user input now. So to first, before getting the user input, I want to give the user, whoever's using our program, like a useful prompt. So first, let's create a little thing right here, and I'm going to create a prompt, and it's going to say, oh, I just realized we don't use println, we want to use print. We're going to say, please enter the track width of the robot. And one thing very useful, whenever you're telling people to enter something, you want to tell them what unit they're going to enter it in. And so that will just allow them to know basically what unit they're going to use. So we're getting the track width, and we're going to store that in a variable called track width. So we're going to say track width equals scanner dot next float. And there we go. We're storing it as a float. We could use a double if we wanted to. No problem with that. You can obviously do it however you want to. No issues with that at all. Okay, next thing, we're going to print out another prompt, just like this, and we're going to please enter the velocity of the front left wheel, and we're going to want that in inches per second, just like that. And I also did the exact same thing. I don't want to do the println, and I'm going to copy this because we're going to need to, actually, one second. First, we're going to go float, and we're going to call this one the front left wheel velocity. You could give it another name, and we're going to do the exact same thing, dot next float, just like that. I'm going to copy this over, and we're going to need this 3 more times for all the different wheels. So front right, back left, and lastly back right. Perfect. And then we're obviously going to need to rename our variables. So front right, back left, and I'm obviously sticking with that camel case, and then back right. Perfect. And then last thing we're going to need to do is finally, because obviously we're going to do our calculations and we're going to get the answer in radians, like I said in the project video. So we're going to call this float, and we're going to call it angular velocity radians. And this is going to be equal to the back right velocity times, no, I'm sorry, plus the front right velocity minus the front left velocity minus the back left velocity. Let me make sure these are right. So back right plus front right minus front left minus back left. And then we're going to do all of this divided by, and then new line here, 4 times the track width. And I'm just going to make this a line, but here, just like that. And just so you know, these are always spaces. These aren't actually tabs. Perfect. It's 4 spaces. And then we're going to need to convert this to degrees. So we're going to go float angular velocity, not radians, degrees equals math class. We're going to use that math class. We don't need to import this one. Dot 2 degrees. And now we're going to give our angle in radians, which it just put in for me. And just like that. Now, one issue with this is that this is saying cannot convert double to float. That's because this math.2degrees function takes in a double and returns a double. So we're going to need to use casting to convert this into a double. And this one right here also, sorry, my bad. We have to put the cast at the beginning. Perfect. And I believe we're also going to need to cast it on the inside as well. Just like that. My bad. Okay, I see what I did here. We're casting as a float, not a double. They already are doubles, so we're casting as a float. This one doesn't have to be casted because this is a float, and then we could cast this one as a double. You don't have to because Java implicitly knows for this one, but it doesn't implicitly know the other way because you're going from something that's smaller to something that's bigger. So double, like it'll go from a float to a double because it can do that conversion and without losing any data. But when you're going from double to float, you have to cast it as a float because you're basically like acknowledging like, oh, we're gonna lose some of that data in here potentially. Okay, so now that we have it, we're going to want to print this out to our user. So we're going to go systemoutprintln like this. So all the other ones were just print, and then we go the angular velocity in degrees is, and then we're going to want to enter our angular velocity in degrees, and we're going to say, okay, actually, I don't want to do it like this. I want to do it like this. So we're going to say the angular velocity is this, and then we're going to say degrees per second because it's not just degrees. Okay, so just like that, we have our solution. So obviously, whenever you're using your thing, and this is, I can close it as well. I'm not going to bother with that, but obviously you're going to want to test your programs and make sure they work. So that's what I'm going to do right now. So I'm going to run my main, and you can see it's opened up my terminal window. It's ran the thing to run the program. So I'm going to say the width of the robot is 10, and we're saying we're going to go, I don't know, 10, negative 10, 10, and negative 10. So we're going to be turning, um, and that's going to give me negative 57.29 degrees per second. So just like that, that should be the answer you get, and that is the solution to our project. So I hope you found this tutorial useful. It was a little bit of a long one, but there's a lot to this, and thank you very much for watching.